Hi everybody, it's Miss Lorenz here. I'm going to talk about lesson 14. We're using fractional lengths in triangles and prisms. So this is a great review of what we did in Unit 1 when we found the area of triangles, rectangles, and we found the volume of prisms. So this will be a good review for you guys. So we had to find the area of the triangle here, triangle A, in square centimeters, and you'll notice that our base and our height are both fractions. So just to recall, to find the area of a triangle, we take the base times the height and divide it by 2. Another way of thinking about that is base times height times 1/2. And we have to be flexible in our thinking because there are times when we might want to think about it this way, and then there are times we might want to think about it this way. Of course, those are exactly the same thing, just a different way to write that. So to go from base times height divided by 2, I'm going to do 4.5 times 4.5 divided by 2, right? Because my base is 4.5, my height is 4.5. So I'm going to think of 4.5 as 9/2. I'm going to do 9/2 times 9/2 divided by 2. So that's 81/4. 9/2 times 9/2. 81/4. But then I'm going to have to divide that by 2. So here I have 81/4 divided by 2. Notice I put 2 over 1 so that I don't get confused about what the denominator or the numerator are. So I've got 81/4. Now I'm going to multiply that because when we divide by a fraction, we multiply by the reciprocal. So I've got 81/4 times the reciprocal of 2 is 1/2. So I've got 81/4 times 1/2, which is 81/8, which is 10 1/8. So my answer is 10 1/8 square centimeters. Here we have this triangle B, and our height is given, but our base is missing. And we have the area, but now we have to find the missing base. So again, knowing that to find the area, we do base times height divided by 2, which is the same as base times height times 1/2. We're going to be able to figure this out. So this time, instead of writing A here for area, we're going to write 8. So 8 is equal to the base, whatever it is, times 8/3 divided by 2. Well, now I'm going to think about my area formula like this. Dividing by 2 is the same as multiplying by 1/2. So I'm going to rewrite that. 8 is equal to 1/2 times B times 8/3. Because what that enables me to do now, you guys, is to multiply 1/2 times 8/3, which is 8/6, and then just multiply that times B, and that equals 8. So now that I have this, I know that if I divide 8 by 8/6, I can get what B is equal to. So 8 divided by 8/6 is equal to B, which is the same as 8 times 6 over 8, because I have to multiply by the reciprocal here, and that equals 6. So I know the value of B, or the base here, is 6. Now, people, remember, there's kind of a lot to these problems, so if you need to pause and go back through, make sure that you understand how to do this problem and correct your work. Make sure that you're doing that on your corrections. Triangle C is a good challenging problem as well. So again, we're given the area and we have to find the height in this case. Knowing that base times height divided by 2 is how we find the area, we're going to be thinking about it again as base times height times 1/2 is another way to think about the area. So I have 54/5 is equal to 3 3/5 times whatever my height is, divided by 2. So now I'm going to think of that dividing by 2 as multiplying by 1/2. So I have 54/5 is equal to 1/2 times 18/5, that's what 3 3/5 is, as an improper fraction, times my height. So 54/5 is equal to 9/5 times the height. So to figure out what the height is, I'm going to take the 54/5 divided by the 9/5, which is the same as 54/5 times the reciprocal here, 5/9, and that equals 6. So we know that the height here is equal to 6. All right, number 4, we have to find the volume of a rectangular prism when we are given fractional side lengths. So the length is 1.5, the width is 2 1/4, and the height is 4, or you could call any of those dimensions any of those. Those are our 3 dimensions we're working with. So I'm going to write 1.5 as 3/2. We're going to turn those mixed numbers into improper fractions. Our 2 1/4 into 9/4, and then our 4, we're just going to write it as 4 over 1. So before I multiply here, I'm going to cancel out some factors. I'm going to cancel out my 4s because I know that there's one group of 4 and 4 and one group of 4 and 4. So now I'm left with 3 times 9 times 1, which is 27, and 2 times 1 times 1, which is 2, and 27 halves is 13 and a half. So we're left with 13 and a half. These are cubic inches since we're talking about volume. All right, number 5. This was definitely a challenging problem. I hope you had a little bit of fun with it. Remember that unit fractions have a 1 in the numerator, and so what we had to do in this problem is find 3 unit fractions that we could add together to sum up to a half. So in this example, we have an 1/8 plus an 1/8 plus a 1/4, and that equals a half. We know that because an 1/8 plus an 1/8 is equal to a 1/4, and a 1/4 plus a 1/4 is a half. So I'm going to try to think of other fraction combinations. We want to be able to use 3 unit fractions to be able to come up with a half. Well, I'm adding a 1/10 plus a 1/5 plus a 1/5. Well, I know 2 fifths plus is equal to 4 tenths, and I know 4 tenths plus 1 more tenth is 5 tenths, and 5 tenths is the same as a half, so I know that will work. I also know I could add a 1/6 plus a 1/6 plus a 1/6 because 3/6 is equal to 1/2. So I'm curious what you came up with. These aren't the only possibilities, so show me what you got, and I hope that helps. Thanks for listening.